and we are going to get started with question number 7. So for those of you who were not in the session on the past Sunday, we did questions 1 through 6, and we are now working on questions 7, 8, and 9. So if you are missing questions 1 through 6, by all means, please go ahead and review the uploaded video of Sunday session so you can get those answers and the work and the explanation and everything filled out. So once again, also, I totally forgot that my Apple Pencil was out of commission. So you'll have to bear with me because I will have to write everything with my finger and it will be horrible. So we have here a chart. It says rates of change of the polynomial p of x at selected x intervals are shown in the table above. What must be true of p of x? So it's saying I have either no minimum, no maximum. It has at least 2 points of inflection, and it is concave up on the interval from -1 to 1. So what are we thinking? Like right off the bat, what are we thinking about?
What's local maximum again?
Well, remember that the local maximum, so if I had like a something like that, this here would be my maximum, this here would be my minimum. So there's my min, my max. Remember that a point of inflection happens when I'm going from an increasing to a decreasing, or from decreasing to an increasing. And then concave up is when the graph looks like that at that point. And so which one are we thinking?
Local maximum. The first one you explained was local maximum, right?
Yeah, well, I mean, the little poopy graph there has both the maximum and the minimum.
Right, but it starts at a negative and then, oh wait, no, there's another negative. Never mind.
I'm gonna go with C
We're going with C. Why?
because it does appear to have a local minimum and a maximum, and it is definitely not concave up on the intervals shown. Like it's concave down. So my process of elimination is C.
I think it's B.
Okay, Nico.
At this point, Nico just wants to be different. So let's kind of, I'm going to kind of do a sketch of what I'm looking at. So at -1, I'm at all the way at -16. Why not? At 0.4, I'm at -0.9. So maybe somewhere around there. At 1, I'm at 0. 2.2, I'm back in the negatives. And then at 3.1, I'm in the positives, right? So if I connected these, something like that. We can agree?
Yes.
So, as Frank was saying, we will do the process of elimination. I'm going to start with D first. So D says that it is concave up on the interval between -1 and 1. So between -1 and 1, my y values are -16, -0.9, and 0. So if you remember in Sunday's session, we had a question that, I can go back to it. I'll go back to it. We had this question here, question number 4, right? So if you can watch the video on so on to see this. But the wording in question number 4 is very, very important because the question says which function must have, right? It's the same idea here. What must be true? So is it possible that at some point between -1 and 0.04, there's maybe another point that causes a concave up on the graph? Is that possible?
Maybe.
Exactly, maybe. So because I cannot say for certain, I'm going to rule out option D. because I can't say for certain that there is another point that creates a concave up, right? I don't have enough proof. And my whole thing here says what must be true, right? So if I can't say it must be true, I can't go with it. Now it has no local minimum or maximum. Well, looking at my graph, right, I can tell that I'm going from negative 0.9. Oh, Lincoln is joining us. Let me... Hi, Lincoln. So make sure you put your name in the chat so that I have the record of everyone who's here in the meeting. And remember that you need to either actively participate or just have your webcam on, and either option is fine. All right, so then continuing, we're looking at the options that say no local minimum or maximum. I'm purposely skipping C for a reason. But I can see that there is a local minimum, right? Because I'm going from that 0, negative 1.2 up to a 0.4. So that creates a minimum value. And it's the same idea as the maximum, right? I'm going from a negative to a 0 to a negative again, which creates that kind of like little peak, little hill. So the answer that makes the most sense is C. I think. I'm pretty sure it's that one. Sorry, Nico. Now imagine I check my workbook tomorrow and it's actually B, and then
How about you not do that?
I'll just make Nico teach the class. All right, question number 8. Which function could be odd? So now this is kind of the opposite of like the question we just did that was asking for specifics. This one is now saying, what's a possibility? Like what could work, right? So I'm going to say a 5th degree polynomial with no imaginary roots, a cubic polynomial with a y-intercept of 0, b, where b is an odd integer, and C, a non-constant polynomial whose graph is symmetric with respect to the y-axis, and D, a polynomial whose output value decreases without bound when input values both decrease and increase without bound. So this one is a bit of a doozy, right? Now, what you want to do here is, first of all, what is the definition of an odd function? You can look in your notes. It's there in the notes. This is like unit 1, 1 point something.
How far back? Because half of my notes like fell out, and the first thing I have is 1.7.
Oh my gosh, Nico.
Is
You
it
need, to
before?
you need to get a new notebook.
Yeah. I don't know where my notes went down, but yeah, it's fine.
Oh my gosh.
Okay, so odd functions are symmetric over the origin.
Which,
Analytically,
okay, pause, Vale, pause. What can I eliminate immediately then?
B, I think.
Not B, read them.
Wait.
C, right?
Oh, C.
It is C, because C says I don't care anything, but it says symmetric with respect to the y-axis, and that is not what makes an odd function an odd function. By the way, what section did you? Oh, 1.5b is what it is, right?
Yeah.
Okay, I just found it so that I can confirm with you guys. So it is symmetric with respect to the origin. So because this is not happening here, C is not what I want to look at. What is another one that I can eliminate based on that origin information?
B.
Exactly, B. Because B is going to have a y-intercept of 0, b. But unless B is going to be 0, 0, it's going to mess up the symmetry. Right? Can we agree with that? We get how that would look?
Yes.
Because the whole point is that it would go through. Oh my gosh. Like,
I'm just writing you like why.
something like that. It has to go through the origin. Otherwise, you don't get the symmetry. So B is another one. So now I'm between A and D. So given this 50-50 guess, what do we want to go with?
A.
What?
A.
Are you saying A?
I'm gonna go with D.
Okay, so we got one A, one D.
Because this whole thing is about symmetry, right? And it says one whose output values decrease without bound, and then the input values both decrease and increase without bound. So wouldn't that make it not symmetrical? Maybe. I don't know.
Oh, actually, I repeal my answer. I put A.
Wait, I'm thinking about D now.
Oh gosh.
Yo, pause.
Also, A doesn't really give any. Well, I don't know. I don't think
Yeah,
that's.
A is not specific. Like
Yeah.
it could go either or.
Nico, are we still thinking about D?
No, never mind.
Sienna, what do we think? A or D? You got a 50-50.
I'm gonna say A.
We're gonna say A. Lincoln, what do you think?
Don't ask me.
Please,
D.
D.
You're going with D?
Yes, sure, why not?
Janae, we have a guess?
No, I don't know.
Okay, so let's see. A polynomial whose output values decrease without bound when input values both. So as Vale was saying, what D is basically saying is that I have a polynomial whose output, whose Y values are decreasing no matter whether or not my X values are increasing or decreasing, right? Because remember that output is your Y and input are your X values. So essentially, it's basically talking about an even function, right? It's talking about a parabola, it's talking about a quartic function where the ends are going in the same direction. So A is actually the only polynomial that would work, that it could be odd. So A was the correct answer to go with. So tomorrow, if you remind me, there is a picture of an example of a fifth degree polynomial that would match it. I think it's something like, oh boy, I'm gonna draw it horribly probably. But I think it looks something kind of like this. Maybe, no, it has to go in the other direction. Like this. I think that is their fifth degree. 1, 2, 3, 4. Yep, that's 5 degrees. That's 5 roots that would be symmetric about the origin. So we see that? So that would be that one. Now, oh, look at number 9. So number 9 is a lot of words. It has a little chart, right?
Mm-hmm.
So let's see. The function k of x is defined for all x greater than or equal to 0. A portion of the graph of k is shown above. Choose the statement that could accurately describe the function k. So as input values increase without bound, output values of the function k become arbitrarily close to 7. As input values increase without bound, output values of the function k of x become arbitrarily close to 2. As input values become arbitrarily close to 7, output values of the function k of x decrease without bound. And as input values become arbitrarily close to 7, output values of the function k of x increase without bound. So I feel like one of the first things we should do here in this problem, because it is very wordy, the answer options are very, very wordy. I would immediately just change that. As x increases without bound, y's of the function become close to 7. I think that makes it a bit more easier to understand, right? And then as x increases without bounds, y values of the function become close to 2. So, and as my x values get close to 7, Y values decrease as X values get close to 7, Y values increase. So what are we thinking right off the bat?
B.
You know, if we're going, okay, we're taking a guess at B.
No,
So
because it is B.
what?
It is D.
It is D?
B. Like there's no guessing.
Oh. Okay, well, if you're going with B, then you can automatically eliminate C and D, right? Because clearly they're trying to confuse you and you want to do a 50-50 kind of deal, right? Yes, maybe.
Yes.
Right. So because of that, now I have to look at my graph. Well, I noticed that my Y values are not really moving, right? They kind of like shimmy and then kind of get a little bit less wavy, but it doesn't actually really decrease. Like I can't look at this graph and say, oh yeah, this is decreasing. Could it? Sure, because it could be on a very, very slow decline, but I cannot see that directly. So I kind of want to avoid the increasing and decreasing because it's not really happening, right? I can't make that assumption, right? So the only ones that make sense are A and B. And then now what I'm really having to look at is what it is approaching. So they kind of try to trick you with A because their arrow is pointing at 7. So I feel like when you initially look at this question, you're like, oh, it's getting close to 7. And you want to go with 7, right? But you actually do need to look at your Y, which is that 2. So B would be the best option, in my opinion. So I would go with B.
Can you explain why it's not C and D again?
Why it's not C and D?
Yeah.
Okay, so you see, Violet, on the graph, that it kind of like wiggles, but then kind of just stays there. I can't say for certain if it's going to increase or decrease, right? Like it's not a clear indication. If the graph had gone something like this, then I would be like, oh, okay, it's decreasing. Or if it went, like this, oh, it's increasing. I realize my highlighting is lagged. So if it's going with the red, I can say, oh yeah, it's increasing. And if it's going with the green, it's decreasing. But I can't see that from this little snippet that they give me, right? Based on this little snippet that I have to pick the answer that is most, like I say, could accurately describe the function. So given that I'm accurately trying to describe the entire function based on this little itty bitty section, the option that makes the most sense is that my graph is going to approach 2.
Right. So what about, like, B also says as input values increase without bound, which is just confusing me a little bit because if we're like making that define like for certain they're not increase or decreasing, why are we like so sure about B?
So remember that when it says that the output values or the input values are increasing without bound, all that's saying is that it's approaching infinity. So it's just saying that your X values just keep going, right? So they're saying, oh, as your X values are going towards infinity, this is what the graph is your Y values are going to look like.
Okay.
That's all it's saying. Because, they're just telling you again, you're looking at a little snippet. So, your snippet ends at 7, but the graph can continue on to like 10,000 or 50,000 or forever and ever and ever. Right?
Yeah. And C and D are also talking about output value. Okay, I understand now. Okay.
Yeah, C and D have to do with the little green and red squiggles that I drew on that. Okay, so now here we are where we are stuck a little bit because I don't have any more any more questions past this because I'm very smart and I left my book at home at my classroom. So I don't know if anyone has wants to like send a picture and we can maybe see about putting it up.
Where would we send the picture?
Can you attach photos in the chat or no?
I don't know. Oh, maybe.
Do not send it on Remind.
You can send a Google Drive in the chat. So if I took a picture and put it on my Google Drive, I can put it in the chat.
Okay, maybe we do that. I mean, I guess if you did it on Remind, I could get it.
Yeah, I'll send it on Remind.
Let's try Remind first and then
We're sending you work on Remind?
huh?
We're sending you our work on Remind?
No, Sienna's sending me the next set of questions.
Oh, okay.
Again. All right, so question number 10. Let Qx and Rx be polynomials such that Q is even degree and R dominates Q for input values of large magnitude. Choose all statements that must be true. So look at that. Must be true. Once again. Oh no, this is one of these. Oh, this is horrible. So these questions are always horrible. Whether it's on an EOC or the SAT or the ACT, this kind of question seems to be the bane of everyone's existence, right? Because they give you so many options and you don't exactly know what to pick. And sometimes they all sound right, but they're usually not. So we kind of want to go through and see. So we have, if the leading coefficient of Q is negative, then output values of Q will decrease without bound as input values of Q both increase and decrease without bound. So what that's saying is output values will be, ooh, I don't want that one, I want the pencil. My output values will decrease regardless of whether my x's are increasing or decreasing, right? That's kind of a characteristic of an even degree function. We can agree with that? And an even degree function with a negative is a reflected one, meaning it's going to go upside down. So whether it's a quartic or quadratic, it's going to go in the same direction, right? So, I mean, to me, one sounds like it would be right, correct? Yes?
Yes.
Okay. I agree. I think one checks out. One looks good to me. The next one says R of x is a polynomial of odd degree. What do we think?
I'm gonna go in now. Because it's an even function, no?
What, R or Q?
Like the equation?
It doesn't say.
Oh.
Ms. Perdomo, in the question, sorry, when it says R dominates Q for input values of large magnitude, what does that mean?
Okay, so it is odd phrasing. Like I've never seen it. That's why when I read it, I kind of paused because I'd never seen it phrased that way. What I'm believing that it means is that when they get into larger values, the R has a greater like value. Like my X values are going to be need to be bigger than the Q one. That's what let me double check. Because I've never seen it
I
phrased
don't
that
think
way.
I don't think 2 is correct then, because I don't think it needs to be odd just to be greater than the even degree that Q is. Like it can be an even number and still be greater, so I don't think it has to be true.
It definitely sounds
Yeah, wouldn't
like
we not know? Because regardless if it's odd or even, it could potentially be greater. So, like, isn't that like not enough information to know if it must be true?
yeah, so like we're saying it doesn't have to be odd. It could be an even value, right? Because I mean, if you pick apart that even without understanding the phrasing, like never seeing it before, like I was just saying that, I can still kind of like pick apart the question and understand what it's saying, right? Such that Q is an even degree and R dominates, means it's going to be larger. It's going to have bigger values than Q when my X values are larger. So that's just, yeah, to me, it doesn't have to be a polynomial of an odd degree. Because, for example, if Q is a quadratic function, then technically a quartic function would have values that are larger, right? Because it's anything to the fourth degree. So it doesn't have to be odd. So because it must be true, I would vote against question number 2. Now, the third one, y is equal to 0 is a horizontal asymptote of the graph q of x over r of x. What is my requirement to have my horizontal asymptote be 0?
It needs to be 0 or greater.
Wait, what?
The graph. I'm thinking that because Q is going to be less than R, then it's going to be a decimal. So then it wouldn't work. So wouldn't it not be true?
Well, what controls my horizontal asymptotes?
That's a great question.
The degree.
Epigraph.
The degrees, right? The degrees of my leading term. So if I don't know, let's say that q of x has a leading degree of x squared, right? What are the rules when I have them as the same?
Oh,
When my leading degrees are the same, what is my horizontal asymptote?
Isn't it the coefficient
It is the
over
fraction,
each other?
yeah, the fraction of the coefficients. That's where the horizontal asymptote is, right? Or if I have the numerator greater, what would be my horizontal asymptote?
you have none? Or no, wait.
I
know
have
the-
none.
Yeah, there's
Okay.
I have none unless my degree in my numerator is exactly 1 greater than the denominator. In that case, I have a what asymptote? What is the third asymptote?
A 1.
Oh, let's go through the game.
I'm gonna go A.
8.
A. Yeah. Slant.
There we go. A slant. Frank, you should know this. We did this in Sunday's review.
Yeah, I don't have a memory for that.
So you have a horizontal asymptote, a vertical asymptote, and you have this slant. So the slant occurs when the numerator is exactly 1 greater than the denominators. Now, what if I had this? What would be my asymptote?
0.
This is when the asymptote is 0. Now, would option 3 be a good statement for this situation?
Yeah.
You say yes, Violet?
Because if R is going to dominate or whatever, it's always going to have a larger, we could assume that it will have a larger degree, and therefore, wait a minute, can't we not make that absolute because we don't know if it's going to be exactly 1 greater?
You cannot make that assumption. Not because it can't be 1 greater, but who's to say that, for example, right, it can't be, this business going on over here. So I'm really looking at these two, right? So obviously this can work. This one can work out, right? Based on what we're saying about R having a higher degree. But who's to say that, for example, they have the same value, but the coefficient on the denominator is larger than the coefficient in the numerator. Would that not also give you larger values? Like if I had x squared plus 3x or plus 3 over 5x squared plus 3, would I not have larger values in the denominator still?
Yeah.
Yeah. And would I have a horizontal asymptote at something other than 0?
Yes.
Yes. So what is the only thing that must be true about the information that they gave me?
This is 1.
Just one. One is the only one that I can say absolutely has to be true based on what they tell me. They don't give me enough information for me to determine the other two things. Right? So we see that?
Furthermore, can you go back to like why the slat asymptote plays a role in this?
Oh, I was just asking you rules of asymptotes.
Okay.
That's
And
why
the
I was
slat is when it's equal 0, right?
slant. Okay, so slant is when the numerator. Okay, wait. Here's what we're gonna do. We're gonna add a new page. So asymptotes. Oh boy. Oh no. This is why I need my Apple Pencil to be fixed again.
Forget it. We'll just review tomorrow.
Huh?
If it's gonna be too hard, it's like review tomorrow.
No, I got it. So asymptotes, you have when, let's say ax over bx squared, the asymptote is going to be at a over b. When I have x squared over x cubed, 0 is where my asymptote is. Now, when I have x cubed over x squared, it is not applicable. There's no horizontal asymptote unless the numerator degree is greater by exactly 1. Then, so therefore, so these little triangle things that I did, Nico, I don't know if you even remember that. Vale, I don't know if you remember that. But in math terms, those little triangle of dots says therefore. So unless the numerator degree is exactly greater by 1, therefore you have a slant asymptote.
Wait, sorry, you lost me on the triangle.
It's just a math symbol. So when you do like math examples, like if you do like if 2 plus 2 equals 4, then whatever, and then you would have like it's like a little triangle made of 3 dots, and it represents the word therefore in math.
Oh, I see it now. Yeah, next to the 1.
Yeah, which is good because when you're in college level math classes, they don't write therefore, they just do that little symbol. So good to know for the future. But questions on the asymptotes then? We're good? All right. Question number 11. Values of the polynomial w of x at equally spaced x values are given in the table above. Which of the following is not a second difference of w of x? So how do I do second differences? Not everyone at once.
You subtract it twice.
I got it. Yeah, I got to subtract, right? So how do I go from -6 to 4? What do I have to do?
-64. Oh,
Add 10.
Add 10. So plus 10. From 4 to 15?
11.
Add 11 from 15 to 2.
Minus 13.
And from 2 to 30.
Plus 28.
28. Now from 10 to 11.
1.
1. There's the 1.
What'd you do?
From 11 to negative 13.
24.
Positive or negative?
Positive.
Ooh.
Negative. Negative.
Negative. I'm going from a positive 11 to a negative 23. So that's a negative 24. That's also one of the options. And then from negative 13 to 28.
Positive 41.
Huh?
Positive.
31.
Positive 41. So my final answer is
41.
what?
Oh, my bad. Disregard.
There can only be one right answer, which is A. We see how nice and easy that was? Just
Only.
calculate the second difference until you get to it. Oh, look at this. The graph of y equals, okay. So you have to help me. Does that say x squared plus 1 over x squared plus 2?
Yeah.
Yes.
Okay. Because I don't have the thing in front of me, so the picture is hard for me to read. So, what does it have? Tell me. How convenient is this section?
It's D. Didn't we just do this?
Oh, is it?
Yeah, didn't we just do that?
I don't know. Did we?
Oh wait, no, it's when the coefficient.
It's 1 over 1, so y equals 1.
So would I have a horizontal at x equals 1/2?
Let's do no x-intercept.
Are you just throwing guesses out there?
Yeah.
Oh my
No, I forgot all these, like,
god. So it does not have a horizontal asymptote because, as Sienna said and Vale said, it's a fraction of the coefficients of the leading terms, meaning 1 over 1. What they did here was try to throw you off by using that 1 over 2 and trying to trick you. So D is not the answer. Now, we have C. It has 2 vertical asymptotes. A, it has no x-intercept. B, no y-intercept. And C has 2 vertical asymptotes. So I'm going to go ahead and just already solve for the x-intercept. Remember, the x-intercept is when your graph, so here's my graph. I'm going to just do here is my x-intercept where my y equals 0, and my y-intercept is when my x equals 0. So I'm going to do both of those, right? Already, actually, I want to do the other one because it'll be easier for me to do. X squared plus 1. So if I did the y equals, that's 0 squared plus 1 over 0 squared plus 2, which equals what? 1/2? So is there a y-intercept?
yeah.
Yes. So B is not an option. Now, for the x-intercept, what's the first thing I want to do here?
Multiply x squared plus 2.
I multiply x squared. Oh no. X squared plus 2 to both sides. Now, over here, 0 is going to stay there, but my denominator cancels out. And I'm left with x squared plus 1. Now what do I do?
Subtract 1.
Uh-oh. Little flags should be going off in our heads. What is happening here?
Uh,
You have to find the square root of a negative number.
And does that work out?
No.
yeah.
What?
No, it's imaginary.
It would be imaginary. Therefore, no x-intercepts. Oh, I didn't mean to do that one. Let's circle it. No x-intercepts. Does that make sense?
Yeah.
And then if I wanted to find the vertical asymptotes, how would I do that? How do I do that? Do I need the numerator or do I need the denominator?
Denominator.
I need the denominator. Remember that asymptotes are restrictions. And when it comes to a rational function, the only place where you can have restrictions is in the denominator, right? Because you can never have the denominator equal
0, right?
0. There we go. So if I did this and I solved for x, once again, the little bell should be going off in my head because what's happening here?
Again, a negative number.
Again, a negative number. So do I have two vertical asymptotes?
No.
No. So I cannot have 2 when I don't even have 1. Right?
Yeah.
And so that is the end of the questions. I need to I might just have to do Office Max or something.
No, you pretty much covered everything. I just need to like go back and redo a lot of these things because I forgot completely how to do asymptotes.
Yeah, so that's why I wanted to take these review sessions. I wanted to take the time to review the unit 1 already. Because like I was saying on Sunday, for those of you who were not there on the Sunday session, we're gonna start unit 3 on Monday, and we're probably gonna finish unit 3 right before the end of April, which doesn't leave too much time to review. So that's why I'm doing these sessions 2 times a week to review the units. So we were a little bit behind, but I'm trying to compensate for that. Also, for those of you, well, actually, everyone who's in this meeting today is only in first period. Let me see.
With a realist.
Okay, so let me see. In third period today, someone asked me about a resource. Let me see if I can share my screen. So someone asked me about a resource. You can see the screen, right?
Mm.
I cannot. This is dumb. I can't see my screen. I can't see my own screen that I'm sharing. Okay. Is it moving?
Yes, moving.
Okay. Oh, it's out of date. Okay, let me reload it. Basically here they asked me about this. It looks good. It is a ultimate review packet. It is a course that you can purchase for $10.99, so it is cheap. It's not too bad, and it actually includes everything, right? So if I go to the free preview, oh, I already did this earlier, but basically you just put in your information, and it comes with videos covering every single topic in the units. It gives you study guides per unit. Because I think one of the issues that everyone seems to be having is that they are not big fans of how wordy the Barron's book is. And I get that, right? So it is, again, this was a brand new course, so that's what the only resource I really had was the Barron's that I saw, which is why I had you guys get that. And it is a good book. It is helpful, and especially when it comes to concepts like this where you want to review it, having the extra words can be helpful. But if you are interested, check out the link that's on the Schoology page for that ultimate review. And like I said, it's only $11, and it comes with videos, practice questions. It's all online, so you can, do it when you're on the metro or something. And I think it's just another resource to help you guys out. Because I feel like this year was a bit rocky. But it is also the first year of this course, so it is going to be a little bit more difficult for you guys in regards to the material, but also a bit easier because the test will probably be a bit more lenient when they grade it.
hopefully.
So, are there any other questions for me?
Yes. Can you one more time explain why there's no y-intercept for 12? Because I understand x-intercept you use the numerator, for vertical asymptotes you use the denominator, but you kind of lost me at the y-intercept.
At the y-intercept?
Yeah.
Okay. So let me erase everything. By the way, if you guys don't have any other questions, you are free to go because I don't have any more questions to do.
Okay.
So
Thank you, bro.
I'll see you guys tomorrow.
Bye, Mr. Demo.
Deuces.
Oh, I'm waving. You just can't see me.
All right.
All right, Vale.
I thank you.
So I have x squared plus 1 or x squared plus 2, right? And actually, I'm going to stop the recording.